You are born in a corridor of metal, not in a hospital, with windows overlooking a busy street, not in a city where the horizon exists, not on a planet where the wind blows and the rain smells of Earth. You open your eyes for the first time, and all that surrounds you is steel, artificial light, and the constant hum of engines that never stop. Earth is a story your grandparents used to tell, a mythology of oceans, of skies that shift color, of open fields where silence is possible. Between you and that place lies a distance. No single human life can cross alone, and you will die before the ship reaches any destination. No one asked if you wanted to be there. You simply are, and there is no way out. This is not science fiction. This is what generation ships truly mean when you stop romanticizing them and start facing reality. Honestly, a generation ship is any spacecraft designed for interstellar travel that exceeds the span of a single human life. The nearest star to Earth, Proxima Centauri, lies 4.2 light-years away. A distance that sounds modest on paper, but amounts to roughly 40 trillion kilometers. To grasp that scale in concrete terms, if the distance from Earth to the Sun were compressed to the size of 1 centimeter, the distance to Proxima Centauri would stretch nearly 3 kilometers. Even with the most advanced propulsion technologies that are technically plausible today, such as nuclear fusion drives or laser-powered light sails, a ship traveling at 10% the speed of light would still take more than 40 years to cover that minimum distance. For destinations more astronomically compelling, we are talking centuries, not decades. Centuries, that means the people who depart never arrive. Those who arrive never departed, and between them lie entire generations of human beings, sons, grandsons, great-grandsons, born, grown, aged, and dead inside a metal structure crossing the most absolute and silent void that exists in the universe. The concept was first proposed with scientific rigor at the beginning of the 20th century, and since then, engineers, physicists, biologists, psychologists, and philosophers have examined it with growing seriousness, especially as telescopes reveal potentially habitable planets orbiting nearby stars. The most obvious question, how do we build a ship large enough, turns out, upon closer examination, to be the simplest question in the entire equation. The hard questions are something else entirely. What kind of society survives intact for 400, 500, 600 years inside a completely sealed environment, cut off from the rest of humanity, with no possibility of expanding its territory? Without the cultural diversity that has always rejuvenated human civilizations throughout history, how does a mission sustain its purpose across generations who never chose to be part of it? And more disturbing still, what moral right do we have to create that society without the consent of the people who will be forced to live it? The founding generation departs willingly, driven by vision, by courage, or perhaps by that particular strain of grandeur that only the unknown can awaken. But their children, the ones born aboard the ship, never made that choice. They are citizens of a state they cannot leave, members of a mission they never chose, heirs to a destiny decided by people who will be long dead before they are old enough to understand what any of it means. To grasp the true scale of this problem, consider what 500 years means in concrete historical terms. In 1525, Copernicus was still developing his heliocentric model. Shakespeare had not yet been born, and North America was being mapped by Europeans for the very first time. The values, the technologies, the social structures, the languages, all of it, utterly unrecognizable by today's standards. Now imagine trying to hold a society together, cohesive, functional, and committed to a single purpose across that same span of time. No new territory to explore, no contact with outside cultures, no release valve, that physical space has always granted human civilizations when internal tensions reached their breaking point. The generation ship is not a propulsion problem with social implications. It is a challenge of social engineering, biological and psychological in nature, of a depth so profound that any orbital calculation looks like child's play by comparison, and the details, when you begin to examine them one by one, reveal a complexity that is genuinely staggering. The problem begins before the ship ever leaves. Before any question of propulsion, provisions, energy, or destination, there exists a biological equation that calls into question every popular conception of generational ships. How many people are needed for a population to remain genetically healthy across centuries of reproduction in total isolation? The answer science provides is far higher than science fiction tends to suggest, and it carries direct, severe implications for the viability of any interstellar mission with human beings on board. Population genetics is precise about the mechanisms that come into play when a group reproduces in isolation across many generations. The first is genetic drift, the process by which random genetic variants become more or less frequent in a small population purely by chance, with no natural selection pressure involved whatsoever. In large populations, genetic drift is slow, its effects diluted by the sheer vastness of the available gene pool. In small populations, it is rapid, and its consequences accumulate in silence, generation after generation. Rare genetic variants carrying disease or disability can become dominant within just a few generations, simply because statistical accident caused their carriers to reproduce slightly more often. The second mechanism is inbreeding depression, which occurs when individuals with close degrees of kinship reproduce more frequently than would be likely in a large population. This increases homozygosity, the likelihood of a person inheriting two copies of a problematic recessive gene, and brings to the surface diseases that, in a genetically diverse population, would have remained completely silent for generations. Rigorous studies in population genetics, applied specifically to the generational ship scenario, arrived at conclusions that completely shatter what most people imagine when they picture these missions. One analysis published in a peer-reviewed scientific journal concluded that to maintain sufficient genetic diversity over the course of a 200-year voyage included a conservative estimate for most relevant interstellar distances included. A ship would need to carry a minimum of 10,000 people, not 500, 10,000. Other models, using different parameters for mutation rates and selection pressure, reach even higher numbers, because this is not simply a matter of avoiding obvious kinship between siblings or cousins. It is about maintaining the population's genetic heterozygosity at levels sufficient for the collective immune system to respond to unforeseen pathogens, ensuring that the species' biological adaptability remains functional and that the generations arriving at their destination are not compromised compared to those who first departed. Compare that number to what historical generational ship proposals have typically suggested. Most of the conceptual architectures under serious discussion work with populations of a few hundred to a few thousand people, driven by the astronomical cost, in every sense of the word, of transporting human mass across interstellar space. A ship designed for 10,000 people is not simply a somewhat larger version of those conceived for 500. It is an order of magnitude different in scale, in construction complexity, in resource consumption across decades, and in the challenges of internal governance. It is like comparing a village to a mid-sized city, except that city is sealed inside a hermetically closed container, hurtling at a fraction of the speed of light for centuries, with no access to any external resource whatsoever. With every generation that passes below the minimum genetically viable population, diversity erodes in silence. There are no immediate symptoms, no alarms. The process is slow, gradual, and practically irreversible without external intervention. And external intervention is precisely what does not exist during an interstellar voyage. There is a technical solution that has been proposed for this problem. A cryogenic gamete bank, frozen genetic samples from thousands of individuals that could be used to artificially inseminate the ship's inhabitants across generations, introducing genetic diversity without increasing the physical number of people on board. The idea is ingenious and technically not implausible, but it introduces a considerable layer of social and philosophical complexity. It would mean that children would be born biologically from parents who never existed on board, that the structure of family and identity would become radically different from anything humanity has ever known, and that maintaining this genetic bank for centuries would depend on technology and protocols that would need to survive intact through every crisis, every equipment failure, and every social transformation that inevitably unfolds within any human organization across generations. Genetics, in short, transforms the generational ship from an aerospace engineering problem into a long-duration problem of evolutionary biology. And every solution proposed at one level of complexity only amplifies the challenges at the next. If genetics represents the body of the generational ship collapsing in silence across the generations, psychology represents the mind and the data that behavioral science has accumulated on what happens to people in confined, isolated environments with no prospect of escape is robust enough that anyone who examines it carefully will pause before romanticizing the idea of a centuries-long interstellar voyage. There is no need to speculate. The studies exist. The experiments have been conducted under conditions that partially approximate those of a ship, and the conclusions are consistent enough to state with confidence what happens to the human mind when deprived of territory, of choice, and of a horizon for extended periods. Long-duration studies aboard space stations reveal that even the most highly trained and psychologically screened astronauts in the world, people who endured extraordinarily rigorous selection processes and who know exactly what to expect, develop predictable symptoms after months of confinement. Growing irritability, fractured relationships with crewmates, disrupted sleep, periods of profound lethargy, alternating with diffuse anxiety, and a phenomenon that researchers have documented and named the third quarter effect, the phase of a mission when collective morale drops sharply and unmistakably. Motivation fractures, interpersonal conflicts intensify in predictable, almost inevitable ways. And this happens on missions lasting mere months, with a meticulously selected crew, with regular communication to Earth, with the certainty of a return home drawing near. Now strip away every one of those mitigating factors and multiply the duration by decades or centuries. The middle generation is by far the most acute psychological problem theorists of generational ships have identified. The founding generation has a clear, deeply felt purpose. They chose to leave. They carry the sensory memory of Earth in their bodies and their histories. They feel the weight and the grandeur of the mission in their very bones. The generation that arrives at the destination, if the ship performs as designed, carries the driving force of being the first to set foot on a new world, with all the symbolic power that entails. But the generations that live in between, those born and who die entirely within the ship, never witnessing the origin nor the destination, occupy a psychological position without precedent in all of human history. They exist. Entirely in transit, belonging to no real place. They do not belong to Earth, which they never knew. They do not belong to the destination world, which they will never see. They belong to a ship, entire, which is a means, not an end, a corridor, not a home. Human psychology was never built for this kind of existence. Throughout the entire history of our species, the sense of belonging to a place The idea that there is a territory that is yours, one that can be shaped, cultivated, defended, and expanded, one that can be hand, has been one of the most fundamental pillars of both individual and collective psychological order. Generational ships erase that completely. There is no territory to conquer, no frontier to push, no natural resource to discover. The available space is fixed, finite, and identical to what it was the day before and what it will be the day after, for decades on end. What long-duration confinement studies suggest is that the human mind responds to this kind of environment through a gradual process of purpose dissolution, a slow erosion of the belief that daily effort carries meaning and that suffering carries sufficient justification. And beyond that, there is the structural problem of authority and social cohesion as time stretches across generations. The founding generation establishes the rules, the values, the hierarchy, and the protocols of the mission. But what happens when the second generation begins to question those rules, having never lived through the context that made them necessary in the first place? And the third generation, who never knew any of the founders personally, not even through direct tradition. The history of isolated human societies, remote islands, medieval monasteries, closed communities of every kind, consistently shows that without mechanisms of cultural renewal and without the influence of external contact, internal tensions escalate to the breaking point. Revolts, factions splitting apart, hierarchies collapsing, essential protocols abandoned. These are not scenarios imagined by pessimists. They are observable, repeating patterns woven throughout human history. In contexts far less extreme than a generation ship, does a social system robust enough to survive intact for 500 years even exist? Within a sealed space, with no external influence and no way out, human history, honestly examined, offers not a single example that provides any comfort. There is a thought experiment that engineers who work seriously on generation ships often use to illustrate the fourth great chasm between the idea and the reality. List every mechanical, electronic, biological, and computational system that would need to function without critical failure for 500 years in order for the mission to reach its destination. Then ask yourself, what is the most complex technological system humanity has ever built that continued operating without external maintenance for 500 years? The answer is disturbingly simple. There is none. Technological complexity and longevity without external maintenance are, in practice, inversely proportional. The more sophisticated the system, the more points of failure it contains, and the more frequently it demands expert intervention just to keep functioning. A vessel capable of sustaining a human population of thousands for centuries would need to keep operational, simultaneously, and without interruption. A list of systems that defies any earthly analogy. The propulsion system, whatever technology it relied upon, would need to produce energy and thrust reliably for decades with no externally manufactured replacement parts. The life support system would need to recycle air, water, and nutrients in closed loops of near-perfect efficiency. Because any significant loss of essential resources accumulated across generations is mathematically fatal to the entire mission. The internal agricultural ecosystem would need to sustain food production without living soil. The natural pollinators, the hydrological cycles, and the microorganisms that sustain any form of agriculture on a planet. The ship's protective hull would need to withstand decades of intense cosmic radiation, micrometeorite impacts, and the structural stresses of temperature variation without a single catastrophic failure compromising the integrity of the environment within. Each of these systems is, on its own, among the most complex engineering challenges ever contemplated by applied science. Together, they form a system of systems whose reliability across centuries cannot be guaranteed by any known technology. The problem is not purely technical, it is also epistemological, a problem of knowledge. How do you design a system to function autonomously for 500 years when the predictive horizon of any cutting-edge technology rarely extends beyond decades? The materials used to build today's aircraft were completely unknown a century ago. The electronic components fundamental to any existing spacecraft did not exist 50 years ago. Designing maintenance systems for a technology that will inevitably be different at the point of arrival than it was at the point of departure is a problem with no obvious solution within any paradigm of engineering currently available to us. And then there is the question of human knowledge passed down between generations. A generation ship cannot depend on individual specialists to maintain critical systems, because specialists die, and with them dies the knowledge that was never adequately transferred. Each generation would need not only to operate the ship's systems, but to understand them deeply enough to diagnose and repair failures that are entirely impossible to foresee. That demands an educational system of extraordinary consistency and effectiveness, one capable of transmitting highly specialized technical knowledge across generations who grow up without universities, without the rich web of cultural and technological references that drives innovation, and without the global communication networks that today make human learning a collective and cumulative endeavor. What happens when the engineer responsible for the propulsion system dies before transferring his knowledge to a capable successor? What happens when a failure occurs in a subsystem whose original design was lost across decades of imperfect transmission between generations? These are not unlikely scenarios. They are statistically inevitable in any social and technological system sufficiently complex, operating for a sufficiently long time without renewal. External. The fundamental paradox of engineering a generational ship is that its systems must be simultaneously simple enough to be maintained with the resources and knowledge available on board across centuries, and complex enough to sustain human life in the most hostile environment that exists in the known universe. Neither of those two demands is negotiable, and they pull in radically opposite directions. The history of human technology shows that systems which endure for centuries are simple systems, irrigation channels, stone arches, ancient aqueducts. Systems that sustain human life in hostile environments are, by necessity, the most complex we have ever built. A generational ship must be both at once, and that contradiction still has no resolution that satisfies the criteria of any honest engineer who examines it with sufficient seriousness. After examining the problem of consent, genetic erosion, the psychological collapse of intermediate generations, and the chasm between the technological complexity required and the longevity possible, the question that remains runs deeper than mere technical feasibility. The question is, even if it became technically possible, would it be morally right? That question has no answer in any laboratory of physics or biology. It belongs to the territory of moral philosophy, and the debate surrounding it is as fascinating as the technical challenges that precede it. There is a powerful argument in favor of generational ships that transcends even the survival of the species, though the survival of the species is already, in itself, an argument of considerable weight. The argument is this: no generation in history chose the world into which it was born. No human being was ever consulted about the era, the place, the culture, or the circumstances of their birth. Children born in times of war did not choose the war. The sons and daughters of pioneers who crossed continents on foot did not choose the crossing. The world has always been imposed upon new generations by those who came before. And humanity endured, adapted, and found meaning within the conditions it was given in each age. Why should this be any different? Would the ship be fundamentally different from any other form of destiny imposed by history? The generation born within corridors of metal can, argue the defenders of this idea, find purpose, beauty, and identity in that space, not in spite of its limitations, but through them. Just as every human generation has always found meaning within circumstances it never chose, it is an honest argument, and it should not be dismissed lightly. There is something genuinely grand in the image of a human civilization, dedicating centuries of collective existence to crossing the void between the stars, carrying with it not only genes and technology, but culture, memory, art, language, and the irreducible human capacity to find meaning where meaning seems unlikely. If humanity ever launches a generation ship, that act will perhaps be the boldest in all of its history, a declaration that this species refuses to accept local extinction as its destiny, and that there is something within us that looks into the abyss between the stars and answers, not with paralysis, but with the determination to cross it. But there is another point that transforms the equation entirely when one considers the horizon of the next few decades of technological development. Generation ships were conceived as a necessary solution to the fundamental limitation of speed, the impossibility, within the laws of physics as we know them, of traveling faster than light. But within that absolute limit, there are approaches that would eliminate entirely the need for whole generations living and dying in transit. Cryogenic hibernation, though not yet technically resolved for humans, would turn voyages of centuries into subjective experiences of mere days for the crew. Continuous acceleration ships harnessing relativistic time dilation would allow crew members to arrive at their destination biologically younger than when they departed. Cryogenic embryos transported by automated systems and gestated upon arrival would eliminate the problem of consent entirely. No one would live through the journey. And the first human generation at the destination would be born already in the new world, with no experience of any metal corridor. These alternatives do not render generation ships irrelevant as a concept, but they reveal that humanity is only at the beginning of mapping its interstellar possibilities. What the reality of generation ships reveals, when examined honestly and without romanticism, is not a limitation of human ambition. It is a portrait of the profound depth of the challenges that ambition will face when it decides to venture beyond. Precisely because it compels more precise questions, more creative solutions, and a more honest understanding of the true price of any form of interstellar expansion. The child born in the metal corridor, imagined at the beginning of this story, exists today as an unresolved ethical question. Not as a reality. What we do with that question, how we face it, whether we can resolve it, says something fundamental about what kind of species we want to be when we finally possess the technology to go. And you, who have watched this video all the way to this point, if you knew that a generation ship would depart 100 years from now, bound for a planet confirmed as habitable, and that the mission depended on volunteers willing to board, knowing they would never arrive, would you sign up? Leave your answer in the comments, because that answer reveals more about what you value than it may seem at first glance. If this kind of conversation about the real limits and open possibilities of space exploration is what you are looking for, subscribe to the channel. Every video exists to bring to the surface the questions that astronomy raises, but rarely finishes answering. And if you know someone who dreams of the stars and what it truly means to take them seriously, share this video with that person right now.